Our third objective domain is describing the features of computer vision workloads inside of Azure. Now, with this objective domain, we're going to identify common types of computer vision solutions. And we're also going to identify Azure tools and services for computer vision tasks. Let's go ahead and get started with objective domain 3, which is looking at computer vision workloads inside of Azure. Now, this still is a very important section of your exam, which will account for about 15 to 20% of your overall exam. So with computer vision, what this does is allows computers to take in visual inputs, whether this is through cameras or videos or pictures, any number of different inputs, and it'll actually use it to make decisions and classifications. So let's go ahead and get started and explore some of the computer vision options in Azure. So let's go ahead and start with identifying common types of the computer vision solution. Computer vision is actually one of those core areas of artificial intelligence that focuses on creating a solution that allows your AI applications to, quote, see the world and make sense of it. So let's actually think about how computers can see, because we're not gluing googly eyes on a computer. So first, what we have are computers are capable of processing images, whether they're from a live camera feed or from digital photographs or even videos. So for an AI application, it's really just an image, and that image is a number of different pixels, and each of those pixels have values. These numeric values are going to be used as features. Remember, we talked about that in the last objective domain, to train that learning model, and it's making predictions about the image and its context. Now, if we're talking about colored images, there's actually going to be 3 layers of pixel values, and that's going to be red, green, and blue intensities. Now, most computer vision solutions are based on machine learning models that can be applied to visual input from cameras, videos, or images. Why don't we go ahead and review some of those areas of computer vision? The first one that we have is image classification. And this is a machine learning technique where the object is being classified as an image or a photograph. Now, image classification solutions involve training a machine learning model using a set of existing data that we already have that class and we already know what it is. So existing data, we have a set of categorized images. And these digital images, like we talked about, we have a number of different pixels, and those pixels have values. And each of those are used to train the model based on some sort of image class. Now, there's so many different use cases for image classification. We have product identification, disaster investigation, or even medical diagnosis. So you can see here, the image classification recognized this image as a taxi. Why don't we go ahead and explore another area, which is object detection. Now, object detection is a form of machine learning based on computer vision where that model is trained to recognize individual types of an object in an image and identify their location in that image. So when we look at that, we're looking at the class of each object that's identified in the image, the probability score of that object classification. So really what we're saying here, that's that confidence level that the machine learning has predicted the correct class. And then we even have bounding boxes or the coordinates for each object. Now, where you may need to use this is maybe you're trying to evaluate the overall safety of a building. So you're looking for fire extinguishers or maybe any other type of emergency equipment that you have. This is also used in creating software for those self-driving cars or vehicles that have lane assist capabilities. And then you can also use it for medical imaging, such as MRI or X-rays that can help detect known objects for a medical diagnosis. It's really powerful what object detection can do. So let's go ahead and look at semantic segmentation. Now, this is an advanced machine learning technique where individual pixels in the image are being classified according to the object for which they belong. All right, so it's classifying those pixels in an image and it has a predefined set of classes. Now, where this is different from object detection is it doesn't try to predict any type of bounding box around the objects. So where you might use this is in a traffic monitoring solution. What it does is it overlays what we call mass on the image to indicate the pixels that belong to, in this example on the screen, the buses, the cars, and the cyclists with different colors. What semantic segmentation does is it helps you answer the question, which pixel belongs to which object? And in your study guide, we're going to give you a couple different examples of semantic segmentation. Let's go ahead and explore image analysis. Now, a machine learning technique that performs image analysis, what it does is it's generating captions and tags based on the image contents. Now, this creates solutions that combine machine learning models with advanced image analysis techniques that help you extract information from images. And that includes your tags that can help catalog the image or even descriptive captions that summarize the scenes shown in the image. Now, this actually builds on object detection and classification models. And image analysis is really great when we talk about that mixed reality of tools, such as the HoloLens. Let's actually find out a little bit more about our final area, which is going to be that optical character recognition. All right, so optical character recognition, or you might also hear it as OCR, is a technique used to detect and read images. Now, what this is really just processing that printed text inside of an image. So you have a model that's trained to recognize individual shapes as whether it's letters, numbers, punctuation, any other elements that could be included in text. Now this is really handy in note-taking or if you have to digitize forms, maybe medical records or historical documents. Or you can actually scan printed checks or handwritten checks for bank deposits. I know I use that at my own bank. We've discussed some of the different areas, but let's go a little bit deeper of how they can be used. So the next area is going to be the facial detection and recognition analysis. So this is where we're actually using algorithms to help locate and analyze human faces in images or video content. Now, face detection involves identifying regions of an image that contain a human face. Usually here we see that bounding box, kind of what we saw with the object detection. But where object detection and facial recognition analysis differ is that it's returning other information. And that information includes like what we call facial landmarks. So where is your nose? Where is your eyes, your lips, eyebrows, anything like that? Well, with these facial landmarks, they're used to train the machine learning model so that way you can infer other information about that person. So maybe their age or their emotional state. So facial analysis is used to train machine learning models to identify known individuals from their facial features. Now, usually what we call this is going to be facial recognition. All right. So let's go ahead and find out a little bit more for our second area, which is going to be covering Azure tools and services for computer vision tasks. Now, we already learned in our other objective domains that Azure is providing a set of cognitive services, and this has a number of different common AI workloads, and that includes some of our computer vision tasks. So Microsoft Azure provides a couple different services that can help you create computer vision services. We have the computer vision, custom vision, face, and form recognizer. And I'm going to cover each of these in a little bit. So first with computer vision services, this is a great service to analyze images and videos and extract different descriptions. You can create tags or objects and text from using this tool. So when in the image here, we have a caption. It's a group of people walking on a sidewalk. We have tags for the different things that it found. We see that there's no type of rating. We don't see anything adult, racy, or gory. But if we could also use this as if there was text in there, or it can recognize additional things in that image. Where that's going to be a little bit different from custom vision is custom vision, you are training the object detection model using your own images. So there's actually a web-based portal where you can upload all of your own images. You get to provide the label for those images, and then you actually train and deploy the model. Now, this is different than the computer vision because with custom vision, this lets you build and deploy your own image identifiers. All right, so you're applying your own labels. Where with computer vision, you're only using the ones that it has for their visual characteristics. Custom vision allows you to create specific labels and train the models to detect it. Now, with cognitive services, all pre-trained models, the customer, you're going to have to train the custom vision service. Where cognitive services, they're all pre-trained. All right. So while computer vision services provide some basic face detection analysis feature, you can actually get more detailed with the face service. So with a face service, this allows you to build face detection and facial recognition solutions. So again, you can compare faces for similarity, or you can even verify the identity of an individual. So there's going to be a link in your study guide to learn more about the different face services. All right. Next is going to be the form service. So what this does is this extracts information from your scanned forms, or it can be in an image or a PDF. And then it uses that OCR, that optical character recognition, with different predictive models that can interpret that form as data. For example, on the screen, you see an example of a receipt. Well, it can actually recognize and give you the total of the receipt, where it was purchased at, what was taxed, and it can upload that to a different service if needed. All right. So that covers all of our different areas when it comes to custom computer vision and custom vision. So why don't we go ahead and check to see how you're doing with this objective domain with a couple of review questions. With question 1, just reminding you that you're going to have a number of different types, and this is just a type of a question that you can expect to see on the exam. So question 1, you plan to use face to detect human faces in an image. How does the service indicate the location of the face it detects? You're going to choose from one of the 3 answers below. 1, a pair of coordinates for each face indicating the center of the face. 2, 2 pairs of coordinates for each face indicating the location of the eyes. Or 3, a set of coordinates for each face, defining a rectangular bounding box around the face. I'm going to give you 30 seconds to choose your answer. The correct answer is number 3. The location of the detected faces are going to be indicated by coordinates for a rectangular bounding box. So there's going to be a number of coordinates from your eyebrows, your nose, your lips, and that's what builds out that bounding box. Question 2. Which of the following results does an object detection model typically return for an image? Is it 1, a class label and a probability score for that image? 2, a bounding box coordinates that indicates the region of the image where all the object it contains are located? Or 3, a class label, probability, and a bounding box for each object in the image? I'm going to give you 30 seconds to answer. The correct answer is number 3. An object detection model predicts a class label, a probability, and a bounding box for each object in the image. So it's going to have all 3. And that brings us the end to objective domain 3. Why don't we recap what we learned in this objective domain? We looked at some of the different features of some of the most common types of computer vision. Remember, that includes image classification, object detection, semantic segmentation, image analysis, optical character recognition, facial detection, facial recognition, and facial analysis. We also looked at some of the different tools that you can use for computer vision tasks, which included custom vision services, face service, and form recognizer. Again, just a reminder that this is going to account for 15 to 20% of your overall exam.